So welcome everyone to starting with Git or intro to Git and GitHub training. The goal of today is to learn how to use Git from scratch, starting from the very beginning. So that's great for those that haven't touched Git ever. For those that already have some experience, it will be kind of a practice session and also an opportunity to ask questions or things that you are not sure about. We are doing this a few weeks before the grad colloquium because it's going to be the main tool to collaborate in groups, but it's also a very important tool for you doing research. A few housekeeping things. We have the shared document. Feel free to add questions, notes, anything in there is going to be there forever, so you can keep the link. At the beginning, there are a few useful links with kind of the material we are going to cover, some slides, and then I will also add the link to the recording. I'm going to lead this session, and I've also asked Elio to join us as a helper in case you have questions. So the idea is to concentrate any issue, errors, things that doesn't work, problems with Git on the chat, so Elio can help. Also, feel free to ask. I really like questions. There are no silly questions here, and it will be even more useful for everyone if you participate. Are we ready? Hopefully. What's Git first? It's a version control system. That doesn't mean anything, but we use it to track changes in a file over time. So if you ever used Google Drive, a Google Doc will have a history of that file with different versions over time. And you can come back, check that previous version, and also recover that previous version if you want. Git works similarly, but we will see some of the advantages of using Git. We are going also to use GitHub, and this is a cloud-based platform, a website, where you can store, share, and collaborate with others, writing code, but also text and in general results research. And one of the main pillars of GitHub in particular, but also other similar platforms, is collaboration. So there are a few extra features that will allow you to collaborate with a group to develop. It can be code, a software, or it can be a research project. And we are going to learn how to use Git and GitHub because we want to collaborate effectively in whatever we do, in particularly with some research projects that we are going to use or work on during the grad colloquium, sorry. The basic idea of Git is that you have a file in your computer. You tell Git that that file exists and you want to include it in your repository, in your project, and then you cycle over it. You modify the file, add code, comments, wherever you're working on, and then you tell Git again, here's a new version of that file. Come back the next day, keep adding things, tell Git, this is a new version of the file. You control exactly when you tell Git. And this is one of the differences with a Google Doc, where you cannot control when you are saving these versions of the files. And when you are ready, maybe at the end of the day or at the end of the week, you send it to GitHub. It can be to share it with others. It can be to make a backup of your project. It's better to do it often, not at the end of a paper, but again, you are in control of how you use the tools. So I already mentioned the word repository. A repository is going to be a folder or a directory in your computer, or it can be in Gadi with files inside that folder. It actually can be as complex as you need, like with many folders and files organized in some way. When you initialize Git or initialize a repository, that folder becomes a repository. And at the beginning, those files will be untracked, so Git won't pay attention to them. Up to now, everything is happening locally in wherever computer you are working on. When we do this in practice, we'll see how the folder looks like and what are the elements inside that folder. So let's say we have a Git repository. Now we are going to see how the workflow of using Git looks like. So let's say we have a file here. At the beginning, when the file is new, it means it's untracked. Git won't pay attention to the file and it's like it doesn't exist. But then we can tell Git, hey, we need to track this file. We need to include it to the repository. It's important in the project. I want to save the versions of this file. And when that happens, we'll have a two-step process to work with Git. At one point, the file will be staged, and we're going to look a little more deeply into this later, but the idea is that we are telling Git, hey, start paying attention to this. I'm going to add the file to the repository, and then we commit it to the repository. If adding a new version of that file into the repository was similarly to taking a family picture, the state will be bringing everyone together to a specific place to take the picture. And we may want some of the people in the picture and others not. So we are going to see how we can include in the repository some of the files and others no. And then when we are ready, we commit the files in repository or we take that picture of the family. And this is the same as telling Git. And this again is going to happen all the time. Every time we want to save a new version of the file because we have a new function in the script or because we've created a new figure in a notebook, we'll edit the file, add whatever we want to do, and then again do a commit to incorporate that new version of the file into the repository. And finally, why we are not using Google Drive. So I mentioned that it works in a similar way. So Google Drive is great for collaboration. It's great for sharing things, but it's not great to work on code. It won't be easy to share a Jupyter notebook, for example, or even a text file. It won't be easy to share. And also, we don't have control over what Google Drive does. We cannot control when we are saving a new version of the file or exactly what we are saving. So it's hard to work that way when we can specifically tell Git save this or that and not that other thing. It's also great to collaborate with others to review whatever we are doing or ask others to review what we are doing. And it's actually the main tool to share whatever we produce in science. So we have the papers, those are published in journals, but the code or tools or whatever produces that paper is generally shared through Git, GitHub, or some of the other options. And that's why we're here today. So this is kind of how Git works. And I'm going to pause here to let that sink and wait for your questions. So we have a question in the chat. Is Git local? Do you have to log onto GitHub to use it? That's a good question. The first part of what we're going to do now is working with Git locally. So in your computer or on Gadi. And then we are going to see how to connect that with GitHub. And to be able to do that, we'll have to give GitHub permissions to talk with Gabi, for example. So we'll have like kind of two versions of the same thing. Your local version, your local repository with everything and is where you work. And then kind of like a backup or remote repository that is going to be on GitHub. And actually you can access these repositories either way. And you can actually make changes also on GitHub and bring those changes to your local repository in Gadi. Another question. Do you recommend creating GitHub account with uni email, which we may lose access in the future, or personal? Both. So in GitHub, you can associate more than one account. So maybe I will create the account first with your personal email, but also associate the uni email you have. And that's because you will get some extra perks if you do that. You have an educational account, and that will give you access to tools, like some free tools. And you can always update that information. So I've had different emails over time, and you can switch around. So even if you lose access to your uni email, if you make sure that you change it for a new email, you'll be okay. Great question. Thank you. Okay, so to work with Git locally on Gadi, we have a few options. First one is to work with Git through the terminal. And that's what I'm going to show you today, at least at the beginning. And I am going to walk you through how to work with the terminal too. So it's two for the price of one here. And this is because in Gadi, you may need to work with the terminal anyway. So it's a good idea to learn how to do that. And Git is by heart like a terminal tool. So everything will be made for the terminal. There are also graphical interfaces you can use. With Gadi, we have some limitations because not everything is installed in Gadi. But if we have time at the end, I can show you how to use Git from Jupyter Lab, for example, if people are interested in that. But for now, I'm going to log in into ARE and open a terminal. I invite you to follow me along with this. You can, perfect. You can use the terminal from ARE, or you can use the terminal from your computer. Whatever option is more familiar to you will be the same. So the terminal is here. Gadi terminal. And this is going to automatically connect you to Gadi. I'm going to click. And this is how it looks like. Let me know if the font size is enough for you, if I need to make some zoom. And I'm going to wait just a little bit so people can get to this same point. Also, we are doing an exercise at the end of this that requires you to be part of a remote repository on GitHub. So you're going to get an invitation. You don't need to do anything right now, but at the end, you will need to accept that invitation to be part of the repository and do the exercise. If there are people here that already did exactly the same last year, you're already part of the repository, you won't need to do anything. Okay, so I'm assuming font size is okay and everyone can see my screen. This is a terminal for those that haven't used it before. So this is a way to interact with a computer. In this case, we're interacting with Gary. And by default, you will land on your home directory. The way to know where you are in Gary is with this command, pwd. I'm assuming it's path to working directory. And when you press enter, it will return exactly where you are. So in the folder home, there are some folders with numbers and then your username. In your case, it's going to be different, of course. This number may change. It's how the file system works in Gary. And then you will see your username, not mine. And you can also list the files and folders you have. So if I press ls, you get the list. So ls is from list. Here in light blue, you have folders. Files are in white. These green things are special files that have extra permissions to execute things. So this is a script. And this is probably a link to a different folder in other part of Gary. So we only have 10 gigabytes in our home directory to work. So we have to use it carefully. We shouldn't put data in here or anything that's too big. But your research projects, your repositories can potentially go here. If your repository is too big that you cannot put it on your home directory, you're probably doing something weird. Repositories are usually not big folders. I'm going to work on my home directory and I'm going to start my new project. To do that, we need to create a new folder. And we do this with make dir. So make directory. And then the name of the folder. I'm going to be very descriptive here and call it my project. You can do the same. We don't need to think about names too hard today. The only thing I will suggest is don't add spaces to your folder or file names. When I press enter, the terminal doesn't return anything, and that's okay because it means that it worked. And we can check that it worked by listing again all the folders and files. We have here a new folder, my project. If people start having any technical question or problem, please ask on the chat, in the general chat, or Elio, so they can help you. I'm going to get into the folder next. And to navigate in between folders in a terminal, we do cd. That comes from change directory. And it's not like I'm very quick at typing. You can use tab to autocomplete. So if I start writing automatically when I press tab, autocompletes to my project, because there is the only folder with the name. Enter, and now I'm inside that folder. So I can check with pwd, and it returns the path to where I am inside my project. So currently our research project is very, very simple. It's only a folder. I see, and it is an empty folder. If we do ls, now it returns nothing because there is nothing to show. Next week in the next training, we're going to discuss how a research project should look like. What's the recommended folder structure to work with a research project. For now, we're going to add a few files without thinking too much about organization. But the first thing we want to do now is create the repository. Right now, it's just a normal folder. We want to create a repository. So this is going to be the first git command we use. So git init. And this is a command you use one time per project. So it's one of the ones that you probably don't remember much. I'm going to press enter. And here we have something. Git usually will give you hints about what to do next. And the hints are usually very useful. So I recommend you to pay attention to them when you are just starting and you don't really know what to do. So in this case, it created a repository. At the end is saying initialized empty git repository in the exact location we are. And it is showing us this .git thing. This is a folder, it's a hidden folder. If you do ls, you don't get anything. If you do ls dash a, then now you get this .git folder hidden. This is where all the information for your repository is going to live. All the history of your repository will be saved. If you remove this folder, you are removing your repository. So it's a folder that is hidden because we don't need to think about it, but we also shouldn't touch it. The other things that is telling us is that we are using master as the name for the initial branch. We're not going to talk much about branches, but this is a kind of like an old version of Git. We used to use master as a name. Now the preferred name is main. So for some reason, Git is suggesting to change the name of the branch. If you got this same message, you can do the same as me. but you're not, you don't really need to do it. It won't change or affect what you do today. So I'm going to type the recommended command in the hint. So we are doing git branch -m to modify the name of the branch from master to main, and that's it. And before I stop for questions, the other git command you are going to use, but this time a lot, is git status. That you may imagine it gives you the status of the repository. In this case, there is no commits yet. So this is a very, very brand new repository with absolutely nothing in it. Questions up to here? Do you want me to repeat any step? Is there anything that's not clear? I think Monash people are having fun there. That's perfect. I think I forgot to mention in the shared document at the end, you will have the list of all the Git commands we are going to use. So you can always come back there and check. I still recommend you to type everything today with me. So in case you get any errors or problems, we can help you. But everything is also there. Okay, so I'm going to use clear. This command is to just clean the terminal so you can better see what I'm doing. And now we are going to start with this process of creating a file, getting Git, modifying the file, getting Git, that we have a new version. And again, for now, we are only using Git locally. We are going to use GitHub in the second part. And I'm showing you how to do it from the terminal here. You can later decide if you are okay with the terminal, or if, for example, you're used to working with Jupyter Lab, you can also use the visual interface to do all the Git stuff I'm going to show you today. Okay, so to create a file from the terminal, in this case, a text file, I'm going to create a Python script. I'm going to use a text editor. My preferred text editor is Vim. If you are used to using something else, it's perfectly fine. I'm going to show you how to use how to use Vim and how to get out of Vim, because that can be tricky sometimes. So we do Vim and the name of the file. Let's do something that everyone may find familiar. Read era5.py. The file doesn't exist, but we are going to create it this way. I'm going to press enter, and now I'm inside the file. So I can start adding text. This is another way of developing code. It may not be the nicer way of developing code because we prefer using a visual interface, getting the documentation and all that, but it's still an option. As you can see on the bottom, it says new file because we haven't saved it yet. So to start inserting text on Vim, I'm going to press I. Now it changed to insert. And for now, I'm going to add just a comment. Read era5 data. We are going to work through these cycles of modifying the file, telling it, and so on, so we can see how it works. I'm pressing the key escape, and now :WQ that appears on the bottom of the screen. W to write, Q to exit the file. Enter, and I'm back to my folder. Now, if I do ls, I do have a new file called read era5. And here's where you start doing git status all the time. It is different from before because now we have a new file. Let me move a little my screen so everyone can see the bottom part of the screen too. Hopefully that's better. Okay, so people are stuck in insert mode. Let me come back to the file. Beam, read, tab to autocomplete, enter. I'm inside the file. If you press I, you are in insert mode. You press escape, you exit insert mode. So I edit the file, escape, you are not editing the file anymore. And now :W key. So hopefully you can now see the bottom of my screen a little better. Enter, and I exit Beam. So Beam can be a little tricky sometimes, but it's very fast to work on the terminal. Hopefully you won't get stuck inside the Beam anymore after this. Coming back to the Git status, again, it says no commit yet, so that means we don't have anything in the history of the repository. But now we have an untracked file. So this is a new file. Git is not tracking the file, is not paying attention to the file, but as I mentioned, Git will give you hints all the time of what you should do next. In this case, add the file to be committed. So if we very quickly come back to this, we are currently in this state, untracked. Now we are going to do add. So we are going to stage the file and commit it. So gather the family to take the picture and then take it. And as I mentioned, this is a two-step process. So first we do git add and the name of the file. And again, I'm very lazy. I never type the names of the files 100%. I use tab to autocomplete. Enter. And usually we'll do the next step very quickly. I'm going to first show you Git status again, so we can see all the stages. Again, it's different. The different thing is that now the file is not untracked. Now the changes are to be committed. This means we're going to add them to the repository. How we can do that? Well, in this case, it doesn't say. The hint will tell you how to undo this. So it's not very useful in this case. Git is not perfect. It is useful, but not perfect. How we do the next step, the commit step, we do git commit -m. This is for message. And we have to write a message that will be associated to that snapshot in the history of our repository. We have to do it between quotes. And even if it's, if you don't know what to say here, it's good to make the effort and write something that is meaningful to whatever you are including in this commit. Because that is going to be shown in the history of the repository. And it is going to help you in the future when you want to come back to what you did a few months ago. And it will be easier if you're saying things that are like reasonable to what you did. In this case, create read error5.py is more or less reasonable. Enter. And if everything went well, we have something like this. In this case, it's saying that one file was changed in this commit and one insertion. One insertion in this case means that one line in that file was changed, or in this case is new. It's just the comment we added before. And with that, we've created our first version of the files, our first snapshot in the history of our repository. Let's practice this. So I'm going to give you a few minutes for you to try this again. So open the file, write something. It can be, I don't know, import XRI, save it, and do the process of git add and then git commit. And after you do that, we'll be back. I'm changing the screen to the exercise. And if you finish doing that, like maybe point 1 and 2 of this exercise, you can put in the chat done or thumbs up or something to see what's the temperature of the room. I saw a few thumbs up, so I'm going to also do the exercise. So we have something similar, but you can still work on your screen. Okay, I don't see the chat on fire with questions and problems. Can I assume that everything went well, or do we have questions? All good. Everyone agree with the chat? Hopefully. If not, again, please use the chat, make Ailey work. We are here to help. So I did the same. If we come back to the file, now it has something else. And actually, let's keep adding things. What else can we add? Another import. Why not? Colon WQ to exit and save the file. And now I'm going to do the process again. So git add, rate error 5, git commit -m, and M is for message, and that's what I'm going to keep adding. Add import S and enter. So now we have something else. And like every commit I've done is one snapshot in the history of my repository. And that's what you're going to check if you want to come back to a previous version of the script or whatever you're using. When we get to the GitHub part, we are going to see how the history looks like in the web interface, and it's really nice. But we can also check the history of the repository locally from the terminal. For that, we use git log that it's going to return each commit in the history of the repository in this nice way. And so it's going to start from the top, the latest commit, going down to the older commits. So this big thing is the SHA. So it's a string of characters, letters and numbers that represent the commit, and is a unique identifier. And then the author of the commit and when it was done. And here we have the message. That's why it's important to write a meaningful message. A few other things that may be important is that head is the last commit in your local repository. You may not need to know this right now, but in time it may be useful to understand what head means. But yeah, you can check the history of your repository, and if you wanted, you can say, hey, all the things I did before doesn't make sense. I'm going to start over by coming back to this first commit. that's an option that's possible. I'm not going to show you how to do this right now, but know that the option exists. Okay, we have the local repository. We've practiced a little bit how the workflow looks like. So creating a file, working on the file, doing add commit to track the new changes in that file and put it in the repository. Now we are going to switch to GitHub for a second. So create a remote repository, and after that we're going to connect the local repository with the remote repository. Using GitHub is not mandatory in a sense. You can work with Git locally and you will be fine. But using GitHub has a lot of benefits, including working with others, sharing what you do, having a backup. So I think it's still very important to work on this. Okay, so I'm going to switch here to GitHub. Probably have to zoom in. And I'm already logging into my account. Here's my face from 8 years ago. If you haven't signed in or logged in, into GitHub, you will have to. If you don't have an account, hurry up, you will need it. But it's okay if not. So this is the main page of GitHub for those that haven't got into here ever. There is some ads about GitHub education, and if you want to check this, you will need to associate your uni account, your uni email. It has a few interesting things if you want to check. And there is also like information, like activity of the repositories and things. You can also check your profile. And I think it is a good idea to spend 5-10 minutes after this, if you don't have anything, to add a picture, add a description, and anything that you find could be interesting for people to know about you. In a way, GitHub is a space to share your work. So now that you are kind of building a career, it can be useful to keep this kind of up to date, tidy, and show the skills you have, the things you produce, and things like that. Having said that, I'm going to create a new repository from this plus or add button here on the top right. And you have a menu here to choose what new thing you want to create. In this case, it's going to be new repository. So again, before we just created the local repository, that's the local version in Gadi or in your local computer. Now we are going to create kind of like a mirror of that in GitHub. And in GitHub, because it's a website, it's going to be published, and you can use that to share your code. That's mandatory now when you submit a paper, for example, or you can use it to collaborate with others. That's what we are going to do during the grad colloquium. New repository then, and here we have a kind of like a form we have to complete. The owner, in this case, is going to be me. But as you can see here, if you have been added to the 21st Century Weather organization, you will be able to create repositories in the organization. And that's totally fine. You can do that. You have permissions. In this case, I'm going to create it in my username, in my account, because it's just a test. And I have to add it a name. I recommend you to use the exact same name you use for the local repository, so you know that they are the same things. It's not, you can add something else, but it's going to be very confusing. So make sure you use the same thing. You're gonna add a description. This is a description for people, so make sure that you add something that's meaningful, that is descriptive of your project. And then you can choose other things. We are going to keep it public today. I always create my repositories as public, because I think that's the best way towards collaboration. There are a few instances where you may want to create a private repository, and that's when you are including data that is restricted, or there is information that is restricted. But we will usually use public. And we're going to keep everything here as it is. We're not going to change anything. We're going to create repository here in green. And now the repository exists. We already have a URL. In this case is Pao Corrales / my project. And currently in GitHub, there is the repository is empty. We haven't done anything to connect what we have in Gadi with this version in GitHub. We're going to do it by following these instructions. But to be able to do that, we need to make sure that we've set up SSH keys so Git in Gadi can talk with GitHub and everything is fine. From what I've seen in the tables, not everyone has done that, so that's okay. We're going to check how to do that now. So first, hopefully you already have the remote repository. Here were the instructions. For those that haven't finished this, now's the time. You can check the instructions in the slides or in the wiki. And now we are going to check if the connection between Gadi and GitHub is ready to go, or if we need to set up that. So even if you've done the configuration, I suggest you to run this SSH-T, capital T, git@github.com to check that everything is good. I'm going to do that now. So I'm coming back to the terminal. Oh, perfect. NCI kicked me out. No problem at all. I'm going to come back to ARE. Click again on Gadi terminal. I'm back to my home directory. This one, I'm going to move inside my project. So cd my _ project, enter. And now we are back to where we are. Where we were before, sorry. So let's check the connection between Git and GitHub. SSH. capital T, git at github.com. So this is actually what you will do to get into things like into Gaudi, for example. In this case, we're trying to get into GitHub. It's not going to let us, but in the process, it's going to tell us if we have permissions to work. It's saying, hi, Pao Corrales, you've successfully authenticated, but GitHub does not provide shell access. This means that you cannot get into GitHub this way, but I've authenticated correctly. For those that this didn't work, we're going to set up the configuration now. So I have the instructions here in the slides too, if you want to check them. But I'm going to come back to the home directory, and to do that, I can do cd and automatically come back to the home directory. This is like a shortcut. And inside this folder, there is a hidden folder called .ssh. So we can check that by doing ls dash a. Somewhere in alphabetical order here, we have the .ssh. So if you don't have that folder, you can create it with make dir.ssh. In my case, I already have it. So that's the first step. Second step, we're going to write this. So let's see if I can play around with things. If people got permission denied when trying to check the connection with GitHub, it means that you haven't set up your SSH keys and you have to follow what I'm doing now. So we're going to create this SSH key that I've been mentioning and repeating, but I haven't said what it is. So it's going to be a string of characters again that codifies your permissions, your authentication to connect with something. In this case, we are going to connect Gaudi with GitHub. You can also connect your local computer with GitHub or your local computer with Gaudi. And that way you don't need to type your password every time. That's a SSH key. So SSH dash keygen -t. This ED 25519 is the way we are codifying this key. Dash C, and here I recommend you to use the same email you use for GitHub. In this case, I have many mails. I'm going to use a new email. And I'm going to press enter. It's going to ask you to create a password. You can skip this step. If you press enter twice, you're ready to go, unless you are in your local computer and you share your computer. But if you're on Gaudi, enter once. In my case, it's telling me if I want to overwrite the key because I already have it. I'm going to say yes. Hopefully I won't break anything in the middle of the training. And then I have to press enter again. And you will get this funny drawing of your SSH key. Are we okay up to here? Okay. So if we check the folder that we looked at before, .ssh, here what I'm going to do is list everything inside the folder. I have many things, but the most important is going to be this file and this other file. So ID underscore and all the things and the same .pub. So this file has the key. This is a secret. You do not share it with anyone. This one is the public key that you're going to share with GitHub. So we need to get the content of this file. I'm going to, we can do, I think, cat and the name of the file. SSH. And when you do cat on a file, it will give you the content of it. So I'm copying this. It's not easy without a mouse. There we go. And now we are going to go to GitHub. So if you've done all the steps I did, you should have two files. One that it says .pub and the other one that it doesn't. If you're not seeing anything, try again following the steps. Okay, back to GitHub. We're running out of time. Let's see if we can finish this step. Okay, I'm going to open a new window and get into GitHub again so we don't lose this. And from here, we need to get into the settings. So I'm going to click on top of my face. And settings. We're going to scroll a little bit and click here on SSH and GPG keys. And here I already had a few keys set up. So this is for my local computer, my laptop. And this, so I can do things between my laptop and GitHub. And this is to do things between Gaudi and GitHub. This is the one I've already broke to show you how to do it before. So I'm going to create a new one. I'm going to delete this and create a new one. I usually call these keys as the same as I'm using it for, in this case, Gadi. And then I need to, I need to copy the key. Where are you, key? Here. Let's see. Hopefully now it worked. Yes. So it's going to look like this. We'll start with SSH, finish with your email. And under this, add SSH key. In my case, I have two-factor authentication, so I have to accept this change. You may not see the same if you don't have that set up. And now I have a new key that hasn't been used yet, so we can check if it works. I'm going to clear this and try SSH dash capital T git at github.com. It worked. I didn't broke everything. Perfect. Hopefully you get the same. Great. In the last few minutes, we are going to now connect our repository in GitHub with our repository in Gadi. To be able to do that, I'm going to come back to GitHub. See, here we have our repository in GitHub, my project. And I'm going to need this URL here. There are two versions of it, HTTPS and SSH. Because we've set up the SSH keys, we are going to choose SSH. Is the best option to connect between Gadi and GitHub if you're working on Gadi. So always choose SSH. I'm going to copy this and come back to my terminal. I'm back to the home directory, so I'm going to move inside my project. And now this is how we connect the two repositories. There are actually a few different ways. We are going to try the easiest one. The git command is git remote add origin. I know this doesn't mean much to you. It doesn't mean much to me either. It's how you connect the repositories. And now we are going to copy the URL we got from GitHub. So git is the command, remote refers to GitHub, and we are adding that connection between the remote and the local repository. And this is how we identify the remote repository in GitHub. Yours is going to be slightly different. It's going to have your username, and if you change the name of the project, it will also have a different name. Going to press enter here. And if nothing happened, we are good. You can always check that this step was done correctly by doing git remote -b. And it's going to return the URL of the repository. So hopefully that's what happened to you too. Going to stop for a minute in case you have questions or you need to catch up with this. Seems that everything is okay. So I have a question. Now that we've connected the local repository with GitHub, have the two things the same? Are exactly the same or not? What I mean is, I'm going to be able to see on GitHub the same thing I have locally? What do you think? You can check, actually. You can cheat and check what you have on GitHub. Yeah, someone on the chat is saying upload. Exactly. We need to sync the two repositories. If I refresh this page, it still shows me this like instruction set up because we haven't sync or upload what we have locally with GitHub. And that's the final step to work with Git and GitHub. So these two commands we have here. Push will be the action to move things from Gadi to GitHub, and pull is going to be the opposite, from GitHub to Gadi. So it's kind of like push to the cloud or to GitHub and pull from the cloud or GitHub. If we come back to the terminal and we do git status, it's saying nothing to commit, working 3 clean. This only means that the local repository is kind of up to date. There is nothing new that we haven't added to the repository. But it doesn't mean anything regarding GitHub. So to sync, to upload everything on GitHub, we're going to do git push. And I think because of the configuration in Gadi, we are going to use origin main. Git push alone, it may also work. Enter. Oh, typo. There we go. So what it did is count the objects in the repository, compress the objects, and then it moved everything to GitHub. And if we are going back to GitHub and refresh, now we do have things. Our lonely read era 5 script. So now things are up to date. If you, for some reason, were to change something on GitHub, let's say we add a new file, or here we add the README, then we will have to do git pull to synchronize the local repository and the remote repository again. And when you're working in teams, exactly what we are going to do during the grad colloquium, this is going to be important because many people are going to be uploading things to the remote repository in GitHub. So we're going to work on managing the project, so deciding who is going to do what, and also being able to always synchronize the repository. So whenever you start to work, do git pull to bring whatever's new in the GitHub repository, so you can start working with the newest and more up-to-date version of the code or of the notebook you're using. We are going to have the whole week, and Paul and me are going to be there to help with whatever you're doing in Teams, so don't worry about that. The good thing about Git is that it's very hard to break things. Everything can be fixed, so it's good to play around and try things. A few things that you're going to see when working during the grad colloquium, and coming back to the slides, is that, first of all, we are not supposed to upload big files on GitHub. There is a limit of 100 megabytes, and that may sound a lot, but if you check your notebooks, they're going to be very heavy. So we'll have to to be careful with that. And there are solutions that we can use to avoid those problems. And one of those solutions is using a git ignore file. That's a list of files and folders that we don't want to put in GitHub or Git. And things like data or very big files are going to be listed there, so we don't make the mistake of committing a big file that then won't get into GitHub. I'm going to stop sharing my screen. We are at the end, in case you have questions. And while we are here, I'm going to share a link to a Google form in case you have feedback. Anything that worked and you want us to keep doing, anything that we should improve for the next time, you can put it there. And before I answer any questions you have on the chat, if you, not only in the next few weeks before the grad colloquium, but at any time you want to start working with Git and GitHub in your project, in your research questions, feel free to write me. We can organize like a short meeting, go through whatever you're trying to do, set up everything, and keep it, make it ready so you can start working. So at any time you have any question or you want to like talk on about what are the things you can do, get in contact. Again, everyone's very, very welcome to next time, same time next week. We're going to see we're going to learn how to use the research project template we have in the center and all the good practices around using that template in terms of how to organize your code, your data, and the documentation, everything around that. So I think that's it. Thank you, everyone, for the questions, for participating. Please get in touch if you need anything, and see you next time.